So at the end of our average rate of change handout, there's a little bit of bonus material, you might say. It's one little bit more vocabulary about how we talk about functions. And it's really its own idea, and it's just separate, and we'll do one exercise. It has to do with what are called increasing and decreasing functions. And the initial statements seem kind of cryptic, and I'll try to explain them, but the exercise is going to be pretty easy, so don't panic if this seems a little abstract at first. So a function is increasing on an interval if for any two input values a and b that lie in the interval, a less than b implies that f of a is less than f of b. Now I want to try to illustrate that idea. So I'm drawing a graph here. I'm working on a graph grid. And here's my A and B. Those are input values. A is less than B, right? So here we got A is less than B. Now, if f of A is less than f of B, well, f of A and f of B are output values. Those are y values. So I could illustrate those here on the y-axis. I could say here's f of A, it's like a y value, and here's f of B, a y value. And notice that f of A is less than f of B because it's lower on the y-axis. Now the point on the graph that corresponds to a f of A is right here. We can actually label those coordinates a f of A because f of A is like a y coordinate. And then b f of B is right here. Now we don't know what the graph of the function looks like, but it's could look something like that. And the graph is rising as it moves from left to right. This is an increasing function. So that's that first statement, or an increasing graph. Now, the statement that comes after that looks almost the same. A function is decreasing on an interval if for any two input values a and b that lie in the interval, a less than b implies that f of a is greater than f of b. The only difference here in these two statements is there's now a greater than sign. So what does that greater than sign mean for our picture? So we still have a less than b. That was the same. But what we're doing is we're saying that f of b is less than f of a. So f of b, the y value corresponding to b, is smaller than f of a, the y value corresponding to a. And now, if I plot my points, the a f of a point is right here, because a and f of a have to go together. And the b f of b point is right here. So notice my graph, which I don't know exactly what it looks like, but it could look like that. And as I move from one point to the other, it's got a different shape now. See how I have a decreasing function graph. So that's the technical difference between this a f of a, b f of b, and this increasing, decreasing business. Okay, so here's increasing, here's decreasing, as always as we move from left to right. And so just again, the easy way to think about it, really all you have to know is that a function is increasing if the graph rises as we move from left to right, decreasing if the graph falls as we move from left to right. So here's a graph that's decreasing, then increasing, then decreasing, kind of like a roller coaster ride. You want to be able to tell where you change from increasing to decreasing or decreasing to increasing. And it's always going to occur at either a valley bottom or a hilltop. Like here's the bottom of a valley, valley bottom. Here's a hilltop. And then we're going to use the kind of the x coordinates of those points are going to be what we're going to key on. And These points are also called local minimum and local maximum points in calculus, but we're not going to introduce that language here. So let's do exercise 6, one exercise here. On which intervals is f increasing? On which intervals is f decreasing? As I go from left to right, I think I can see that I'm increasing, rising. Then I hit a hilltop right there at that point. Then I'm decreasing. I kind of hit a bump, but I keep decreasing. I don't get to a valley bottom till I get over here, correct? Then I'm increasing again. So increasing, decreasing, increasing. And what I want to identify are these x-coordinates. So maybe I'll write in red here. I like this -2, it's already there, and we don't have a 3 here, so I have to write it in. And when we talk about intervals over which we're increasing and decreasing, so maybe I'll write INCR for increasing, DECR for decreasing, INCR for increasing. We refer to intervals of the x-axis where we're increasing and decreasing. So it's like we're increasing, then we're decreasing over an interval, then we're increasing, and it's the x-coordinates of these hilltops and valley bottoms that separate us out. And notice that this separates the x-axis into 3 pieces. I'm going to leave the endpoints off of these intervals. I'm just going to write -∞, -2. Then the one in the middle, I'm going to write -2 to 3, leave the endpoints off, and then 3 to infinity. We leave the endpoints off because at the hilltop, are you increasing or decreasing, or valley bottom? Well, you're really doing neither, right? And so now we're ready to kind of answer the question here is, we can say f is increasing on which intervals? Well, this increasing piece, it's -∞ to -2. But also on the interval from 3 to infinity. So we refer to that interval of x values. So that's part of our answer. And then f is decreasing on just one piece for this graph. You could get several pieces for both of these on a more complicated graph. So we're decreasing just in the middle from -2 to 3. So we say on that interval from -2 to 3. And there's our increasing, decreasing exercise.